Alright, today we're going to represent expressions using manipulatives so you can see what is happening when we're combining like terms and when we're distributing. So our first expression up here says 3x minus 4, and you can see I have some manipulatives over here. This yellow square is representing x, the red square is a negative x or the opposite of x. A yellow circle is just a 1 unit, and the red circle is a negative 1. So I need 3x. That means I need 3 x's. So I'm just going to drag 1, 2, 3 x's over here. Minus 4, well, this would be minus 1, minus 2, minus 3, and minus 4. And that's what 3x minus 4 looks like. And we can see that the x's are different from the negative 4, and we can't combine those or put them together. They're not like. They're not the same. And so we are done with that expression. It is simplified as far as it can be. Let's look at another example. This one is 3x minus 4 plus 2x. So I'm going to start off the same way. I need 3x and minus 4. And now I'm going to also have plus 2x. Now when I look at this one, I do see that I have some things that are alike that I could put together. I've got these 3 x's over here and these 2 x's over here, and if I combine those, what I really have now is 5x minus 4. Let me get a pen out real quick. And so what I have when I combine those like terms is 5 x's minus 4, because I'm able to take my 3x and my positive 2x here and combine those to make 5x. I put them together. They were the same. Let's look at another example. All right. Once again, I have 3x minus 4 plus 2x minus 2. And I can simplify this. I can combine things that are the same. I can take my 3x and my 2 more x's and put them together. I can take my minus 4 and my minus 2 or negative 2 and put those together. And what do I have now? Well, I can see I have 5 x's and I have negative 6 negatives. So once again, I could combine my 3 x's plus my 2 x's, because they were like terms, and then I could take this negative 4 and this negative 2 and put those together, because they were both terms that did not have a variable. They were constants, and we can combine our constants as well. Let's look at another example. 5x minus 3 minus 2x plus 5. Well, let's think back to when we were adding and subtracting integers. Can I put these x's and these negative x's together? I mean, they're both x's. I can. We just need to remember that when you have a positive and negative of the same thing, those are going to cancel each other out. So this x and this negative x will cancel each other out. This x and that negative x will cancel each other out. And we have 3 x's left over, which makes sense. If you have 5 x's and you take away 2 x's, because remember that a negative sign always stays with what's behind it, so I have 5x minus 2x. Wouldn't it make sense that you would have 3 x's left? Yeah, I think it does. And if I take this negative 3 and I add 5 positives to it, well, let's remember back to adding and subtracting integers again. When I add a negative and a positive together, they cancel each other out. They make a 0 pair. So these will cancel out, and I'm going to end up with 2 positives left. So 3x plus 2 is my final simplified expression, because I can combine this negative 3 and this positive 5, and I'm going to have 2 positives left over, because 5 minus 3 is 2. Okay, let's look at another example. All right, we have more than just one x term, or 2x terms. We have 3 of them. We've got 2x minus x plus 3x. So I can combine more than 2 terms as long as they are the same type. So 2x minus x plus 3x. Well, I know that this positive and negative x are going to cancel each other out. So what I really have here is 4 x's, which makes sense. 2x plus 3x is 5x, minus x is 4x. And then if I'm looking at my non-variable terms, my constants, I have, minus 4 and plus 3. And once again, when I put positives and negatives together, they're going to cancel out. So let me cross out my 0 pairs. And what we end up left is 1 negative. Negative 4 plus 3 is negative 1. And there is our simplified term. All right, so that was to help us with simplifying. Notice they had to be the same variable. And they also needed to have the same exponent. If I can get my camera to work, I'll show you at the end of this what x squared would look like and why we can't just combine x's and x squared, because they're different. Let's look at what's going on when we're distributing. So distributing is multiplication. We will see a number outside of parentheses, and that's the number we're multiplying. So this says I need 6 groups of 2. So here's one group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2, excuse my sloppiness, 5 groups of 2, and 6 groups of 2. And if I count these up, that's 2, 4, 6, 8, 10, 12. So 6 times 2 is 12. No surprises there. Let's look at something a little bit more interesting. This says we need 6 groups of x. So here's 1, 2, 3, 4, 5, and 6. Maybe I'll do them this way because I don't have room going up and down. So I have 6 groups of x, and if I can look and see, that is just 6 x's. So 6 times x is just 6x, and that's the algebra way of showing I'm multiplying a number and a variable. Well, when we're distributing, we have something like this. We have 6 groups of x plus 2. So here's one group of x plus 2. Here's a second group of x plus 2. A third group of x plus 2. A fourth group of x plus 2. A fifth group of x plus 2. And a sixth group of x plus 2. Well, we know from combining like terms that I can put all these x's together. How many x's do I have all together? I have 6 x's, and I could put all my constants together. How many of those do I have? Well, I have 2, 4, 6, 8, 10, 12. So I have 6x plus 12. And what the distributive property says is that I can just simply take the 6 on the outside and multiply it by the first term. 6 times x is 6x. And multiply it by the second term. 6 times positive 2 is positive 12. So we end up with 6x plus 12. And this is what you're doing when you distribute using the distributive property. So real quick, I wanted to show you why you cannot combine x's and x squareds, why they had to have the same exponent as well. So these are a set of virtual manipulatives called algebra tiles. And you can see we have the yellow squares. Those actually represent positive 1. And then its opposite would be negative 1. So red is always the opposite, or the negative. We've got this green one. This represents x, so it's an unknown amount. If I were to line up my ones units, it would not be exactly one number or another. This is supposed to represent an unknown. And once again, in algebra tiles, the opposite or negative is always going to be red, so this would be negative x. And then if I do x times x, I get x squared. So this represents x squared. So if I did x rows of x, I would get this x squared. And so this is x squared, and this would be its opposite, negative x squared. So if I had, say, 3x plus 2x squared, I could not simplify that because these are not the same thing. I cannot combine them. Where if I had 3x minus 2x, I can see these are the same, and these would actually combine and cancel each other out, and I could make just x. But I cannot combine the x's with the x squared. I can't even combine negative x's with negative x squared, even though they're the same color, because they're not the same shape. So it does have to be the same variable and the same exponent.